In last class, we derived input impedance of the transmission line. That is Zin equal to Z0 into ZL cos h gamma L plus Z0 sin h gamma L divided by Z0 cos h gamma L plus ZL sin h gamma L. We can write that one in terms of the tan also. That is given by what? Zin is equal to Z0 into ZL plus Z0 tan h gamma L divided by Z0 plus ZL tan h gamma L. So this is the derived equation. Here I am taking this one as equation 1 to discuss this SC and OC lines. What is meant by SC line? Short circuited line. What is meant by OC line? Open circuited line. We all know that short circuit means what? In short circuit, we have the maximum current means minimum impedance. For short circuit line, load impedance must be 0 because for short circuit line, impedance is minimum. So for SC line means for short circuited line, ZL equal to 0. For short circuited line, ZL equal to 0. In that case, we will get what? Here ZL becomes 0. By substituting ZL equal to 0, we will get input impedance for the short circuited line. So therefore, for short circuited line, for short circuited transmission line, that is ZL equal to 0 line, we have the ZIN. ZIN now becomes what? Input impedance of the short circuited line. I am representing that input impedance of short circuit line as what? ZSC. ZSC equal to what? Z0. As we are taking this line as this is the input impedance of the short circuited line means what? ZL should be 0. Here Z0 tan h gamma L divided by Z0 ZL. What is ZL? That is 0. 0 into something 0. Now we will get this one as what? Z0 square tan h gamma L. So this is what? Input impedance of the short circuited line. This is what? Input impedance of the short circuited line. Now let us take this as equation number. This is ZSC. ZSC indicates what? Input impedance of the short circuited line. Now we can write ZOC. For open circuit line, for OC line, that means for open circuited line, ZL equal to what? Infinity. Here we simplified by substituting ZL equal to 0 in equation 1 directly because ZL is 0. Now if I substitute ZL equal to infinity, here I will get what? Infinity plus something, that is infinity, into the Z0. Infinity into Z0, that means some infinity into something, that is infinity. Here Z0, it is something plus ZL, that is infinity. Infinity into something, infinity. That means in the numerator we have infinity, in the denominator also we have infinity. That is undefined form. So to avoid that, instead of substituting directly ZL, I am taking the ZL as common in the numerator and the denominator. Then I will get something by ZL. That something by ZL gives what? ZL is infinity. That is something by infinity gives 0 because ZL is infinity. Here also as ZL is taken as common, here we will get Z0 by ZL. That is something by ZL. ZL is what? Infinity. By substituting open circuit condition, you will get what? Something by infinity. That becomes what? 0. So for that, we need to make the ZL as common in the numerator and the denominator. That means equation 1 can be rewritten as Zin. I am taking ZL as common in the numerator and the denominator. Here what is the remaining term? ZL cancel in the numerator and denominator. Remaining is what? 1 plus Z0 by ZL tan h gamma L divided by, here ZL is taken as common, it becomes what? Z0 by ZL plus, here ZL is taken as common, that is ZL by ZL, that is 1. Remaining term is what? Tan h gamma L. Let us take this as okay. Now for open circuit line, for open circuit line, as ZL is equal to infinity, as ZL equal to infinity, it implies Z0 by ZL. That means something is Z0 divided by ZL. ZL value is what? Infinity. You will get this one as what? 0. Let us take this as in equation number 3. Substitute in equation 3. Substitute Z0 by ZL as 0 in equation 3. You will get Zin as Z0 1 plus, what about this one? That is 0. 0 into something 0. And this one is 0 plus tan H gamma L. Tan H gamma L. That means here Z0 by, we got this one as Z0 by tan H gamma L. Or it is equivalent to what? Z0. 1 by tan is nothing but what? Cot H gamma L. So this is what actually we have to write here for input impedance of short circuit line. We write this input impedance as what? ZSC. Here we substituted the condition of open circuit line that as ZL equal to infinity. Now it should be what? ZOC. Here also it is what? ZOC. Therefore, ZSC into ZOC gives. Let us take this as equation number 4. ZSC into ZOC. What is ZSC? That is Z0 square. Okay. Here, sorry, actually it is what? Z0 into 0 plus Z0. Z0 into Z0, Z0 square divided by Z0. It gives only Z0. Z0 tan H gamma L. Here it is Z0 tan H gamma L into Z0 cot H gamma L. We can write cot H gamma L, or else better to write that as what? Z0 into 1 by tan H gamma L. This tan H gamma L cancel. Finally, we have what? Z0 square. That is ZSC into ZOC equal to what? Z0 square. This is important relationship. Or else we can write Z0 as what? Under root ZSC into ZOC. I am writing this one here. That is Z0 is what? Under root ZSC into ZOC. See here. Simply what we did. For short circuit line, we substituted ZL equal to 0. Directly we substitute ZL equal to 0. We got ZSC equal to Z0 into tan H gamma L. Here Z0 into Z0 square. But in the denominator we have Z0. So that's why ZSC is like this. Similarly, in case of the open circuit line, ZL becomes infinity. If you substitute infinity, that gives what? Undefined form. To avoid that, we have rewritten this equation like this by taking ZL as common. In that case, we got this form, that is Z0 by ZL, Z0 by ZL. For open circuit line, ZL equal to what? Infinity. In that case, Z0 by ZL becomes what? That means something by infinity gives what? 0. By substituting that, we got ZOC as like this. That is ZOC equal to Z0 by tan H gamma L. Or else it is what? Z0 cot H gamma L. By multiplying this equation 2 and equation 4, we got ZSC into ZOC equal to what? Z0 square. Or else Z0 equal to what? By applying square root on both sides, we will get Z0. Z0 equal to what? Under root ZSC into ZOC, like this. So that is the relationship between characteristic impedance ZSC and ZOC. Okay, here I will tell one important equation for ZIL in case of the lossless line. In case of the lossless line. For lossless line, alpha equal to what? 0. Then gamma equal to what? Alpha plus j beta. That is what? J beta for lossless thing. Since alpha value is what? 0. Alpha value is what? 0. That is gamma equal to 0 plus j beta. That is j beta. Now this ZIN can be written as what? ZIN equal to Z0 ZL Z0 tan H gamma. Gamma is what? J beta. We can write that as what? Tan H j beta L divided by Z0 ZL tan H gamma L. Tan H, what is gamma? Gamma is now j beta. Gamma is j beta into L. We know tan H j beta L equal to tan H j beta L is equal to tan H j beta L equal to j into tan beta L. J into tan beta L. So the tan H gamma tan H j beta L is equivalent to what? Equivalent to what? J into tan beta L. In this case, we got Zin as Z0, ZL. This Z0 tan H gamma L now becomes what? Tan H J beta L. The tan H J beta L can be replaced with what? J into tan beta L. Already here you have what? What you have? Tan H J beta L is what? Z0 into tan H J beta L. Tan H J beta L is equal to what? J into tan beta L into this one Z0. So that's why we can write that as what? J into Z0 tan beta L divided by, as here you have Z0. Here it is what? J. What is this? ZL tan H J beta L. Tan H J beta L is equal to what? J into tan beta L into this ZL. That means it can be written as J ZL tan beta L. This is the expression for what? Input impedance of the lossless transmission line. Input impedance of the lossless transmission line. As you know, write this one. That is node for lossless line also. For lossless line also, ZSC into ZOC equal to Z0 square. Okay? Take this one as an assignment. Prove that one. So let us substitute. Let us find the ZSC. That means ZIN for the short circuited line, and find ZOC. That means input impedance for the open circuit line. Then multiply them. You will get this ZSC and ZOC. Then multiply them. You will get this Z0 square. Okay, and if you want this proof, I will write like this. That is tan H J beta L. Tan H J beta L can be written as what? Sin of H J beta L. Sin H of J beta L divided by cos H of J beta L. Already we have the, that is sin H gamma L formula, cos H gamma L formula. Here instead of gamma, here you have what? J beta L. So that's why it can be written as what? As it is, instead of gamma L, you can write beta L. That is e to the power J beta L. As it is sin e to the power minus J beta L by 2. Here cos H J beta L. That is what? E to the power J beta L plus e to the power minus J beta L divided by 2. Okay. So this is equivalent to, in the denominator, this one is equivalent to cos of this angle beta L, cos beta L. And what about this one? In order to get that one as what? Sin beta L. Sin beta is nothing but what? Sin theta is nothing but what? E to the power j theta minus e to the power minus j theta by 2j. So to get that j, multiply and divide with j. Here j by j. So here we are doing what? This one is equivalent to what? This sin beta L. Additional factor is j. Sin by cos is what? Tan. That is j into tan beta L. So this is the proof for what? This one. That is tan H J beta L is equal to what? J into tan beta. Tan H J beta L equal to what? J into tan beta L. In this way, we discussed about SE and OC lines. Okay, for SE line, ZL equal to 0. For OC line, ZL equal to infinity. And additionally, I discussed about what? For lossless line, gamma equal to J beta. Since alpha equal to 0. By substituting that, we got tan H J beta L as what? J into tan beta L. For that, here I have written proof. Okay, simply I will tell this. Sin theta is equal to what? E to the power j theta plus e to the power minus j theta by 2j. Similarly, cos theta is what? E to the power j theta plus e to the power minus j theta by 2. Here j. In order to get this additional j, we have multiplied and divided with j. This one is equivalent to sin beta L like this, and additional factor of j is like this. Finally, we have this tan H J beta L is equivalent to what? J into tan beta L. Okay, so this is the topic of short circuit and open circuit lines. We will meet in next class.